Hello, hello. In this part of the streaming series, I will be working on handling particles dynamically. Uh, so, yeah, right now we set up a base particle. This is one bullet. Um, and we mostly did it to test out our systems. Let's see, I didn't change this one. No. Our renderer doesn't need to change right now. So right now we're working on, uh, let's see, maybe we want another test flag. We will start working on something to happen when we press the F2 key. Uh, let's move that into here because, yeah, we want that to be created whenever we press F1, but now we would like uh, let's see, to clear the particles whenever we press F2, because we want to create them dynamically. So we would like for it to be dependent on our camera. We would like to spawn a projectile coming from the camera. So let's see, our camera has get the position. We should also be able to get forward, which will just be our looking at vector. Let's see, let's just clean up this stuff. So yeah, now we can get, whenever we rotate the camera and so forth, this gets updated. So uh, uh, if we look at our particle code here, we can actually just implement it. The position has to be whatever camera position we have. So therefore, the camera position has a value of 0, meaning that, let's see, it's inside the physics. And we just want the camera controller to get our camera, to get our position. We will be accelerating downwards in terms of gravity. Maybe even less, because we don't want a lot of dampening. Let's start out with 0.5, and then lastly we initialize the direction to our forward going motion. But we would like for it to have a slight modification, or rather, maybe we don't want it to. Maybe we just want to multiply whatever direction we're looking at. Yeah. Let's see. Do we have a math function? So we have store float, multiply scalar. Yeah, so we can just do it for one. So if we do, the velocity is our math multi scalar, and we want to get our camera controller, get camera, get forward, and we want to multiply it by, yeah, let's start with -10, or maybe just 5. This will make it move slow enough that I think that we would be able to see it. Then we add the particle by moving the particle. Then let's do some checking. If not, we want the to do this for the particles. Let's do some adding to our game objects. And then do some renderer submission. Let's see. Since we want to access it, there's no reason to move it. Let's just copy it in. And yeah, the code is the same. So this creates the, and so far this is supposed to do the same thing, right? Let's see. So we actually created an object but the forward-going velocity wasn't much. You can see it's spawning. Well, the backwards go, the vector rather seems to be pointing backwards. It keeps on updating, but it clamps the Y position. But it actually keeps on going. Let's see. That means that this part of the code works, but I think we would like to multiply this, which is a unit vector. So let's try 250. Well, uh, well, yeah, it probably just disappeared. Let's see. Whoops. I wanted to move the camera. So yeah, it just flies off. And now we're spawning particles everywhere. Let's just do 150 perhaps. So it flies off into the distance. Let's see. And it stops there. So it travels pretty long. But yeah, that seems to be working. If I kind of change the camera, yeah, it does get the angle, but it gets rather shorter whenever I angle it. And it probably won't get far if I do like this. Well, it does still slide a lot. If we do increase the dampening, it will experience a lot of friction. Let's see. Where did it go? Did it fly off or did it just get stuck in the wall? Let's see. It just flies off. Yeah. Yeah. So a low value means a lot of resistance. Let's see. Yeah, but of course we would have to, right now we just kind of artificially collide with the floor, but yeah, we could do like this, make it stop. So whenever it hits the floor, it actually stops. That is perhaps a bit more realistic. Now it doesn't matter as much how much dampening we give it, because now it will just stop whenever we hit the floor. So like that, we shot at the floor. I know it's not very accurate, this simulation, because the object doesn't rotate. It's meant to be a basic particle, so it could be for either reason just be a point in space that we translate into a particle in our rendering pipeline. Maybe we will do that as the next part. So yeah, right now we fire off a bullet whenever we press F2. And actually we could add a simple key press here that allowed us to test out what happens if we repeat the state. And we set the flag to false. Let's try that. We might run into some bugs. Which we don't. We are actually allowed to spawn new bullets. And we have our own firing mechanism. Let's try firing up in the air. Oh, and we have something that went very far. Maybe the gravity is supposed to be a bit stronger on each object. Maybe just a bit. Yeah, that seems a bit better. It flew off into outside the far plane of the camera. All right. This does some sort of let's see. I think that if we do it fast enough, things will stop in the air. Yeah, I didn't even finish my sentence before that happened. And actually a third bullet flew off. And so yeah, right now we would like for our renderer / game loop to actually update all of the created particles. They are updated in terms of math, but they are not updated in terms of view projection matrices, which was the pickle that I ran into earlier. I could do 2 tracking vectors, although I do feel like tracking vectors are somewhat janky. I mean, we have some particles. The loop should be spawn particle added to the particle vector / list. Create the game object. Right now we do particles in terms of small game objects. Create the translation. We could do that differently with a specific particle system inside the renderer. Right now I think it's fine that we treat this as a object, because this physics engine will be a stepping stone towards actually doing rigid bodies. Therefore, we will end up in a similar situation. So it has a transform index. Then for each frame, do physics, get a list of 30 objects plus transforms, update the renderer with the new data. So we have the logic separated here. We are already able to spawn a particle, create the game object, which has a game object ID and a transform index, or rather a transform, which has an index inside our vector. So right now we have different vectors that are not synchronized. We create game objects and transforms and particles. We could do a function that passes whatever IDs these particles get. We could also do what is called an SCG pair. Yeah, so a vector of vectors are probably better. Yeah, so we could do that instead. Yeah, let's just call it IDs and do it as unsigned ints. That will do some tracking for us. I'm not sure whether this is the right way to do it. It's probably a fairly cheap way to do it. So So if we do particle IDs, we add a vector of ints, unsigned ints, object ID. Let's see, we do not overlap, and transform index, and we create in place a object ID and create in place a size -1. Let's just move the object ID and move the transform index. So we need to now calculate matrices for each of these. This will end up having the same size as the particles. Let's clear it. Now well, maybe this is not supposed to be doing like that anyway. We do not want to clear the particles. Anyway. So now we update all our particles. We make sure they stop whenever they collide with the plane. Then we would like to iterate. Maybe I want to store the game object index instead. Because it will be faster instead of just searching for the ID. Yeah, I think it will be way faster. Because why do we need to fetch the actual ID right now? I don't think we need it. Object index, and let's change that into the game objects size -1. Because that allows us to do something like, let's just use an index in case we need it. Particle IDs, size. And then will contain whatever Let's see, object index equals that, then R transform index equals that. We could do checking here to see if the particle is dead or whether it needs an update, but anyway, let's see. If we do game objects 30 equal to true, then for let's see, maybe we so we set that to 30 because right now we are updating all particles. We're not handling whether they collide and whether they should be not updated anymore. We want to update them every time, at least for the time being. Meaning that the dirty flag has to be set, but we also need to recalculate the specific particle. It would be faster if we just did this for every object, probably. But right now this would suffice, I think. It should should collect a list of maybe we want to separate this actually. Maybe we want to separate it. Let's see. Maybe when we create an object, we actually want it to store its transform. Maybe I'm running into trouble all the time because I can't fetch the transform. Yeah, maybe I need to change the way this works. maybe it's just wasteful to store the ID on the transform. Then you could always add the index to a sort of queue in terms of available buffers that are not longer in use whenever a specific ID gets invalidated. Yeah, maybe this is better. Maybe this is better. So we got a lot of errors here. So for this object, we do not store the object ID anymore. Therefore, we can actually create the transform first. And then is equal to the transform size -1. Let's see. I mean, the object is just a sort of data container which knows what indexes to look up whenever we want different properties. If we iterate over the data fields of the objects, we can know if they have certain features or rather components. If it's not invalidated, we know it does have something to the effect of a yeah, I think that is more correct. Let's test it out at least. And we want the object temp transform to be as before, the size of that -1. In multi-threaded code, this would probably have to be done through some allocator instead. We do not need that for now. So we just create empty transforms. Whoops. Yeah, and then our renderer will have to be updated because now that doesn't know how to. Well, maybe this gives us problems in terms of allocating the let's see. Let's see. Transform index. Hello, welcome. Let's see. So we get the transform ID here. We don't have to allocate it like that. Yeah. Yeah. I've started doing the physics. Let's see if this actually works. We need to. Uh, um, since I started the YouTube series, so let me check if I do. Can I find my channel? Oh, well, just another bad programming guy. Let's see. Uh, oh well, YouTube. Whoops, comma instead of a dot. Thank you. Let's see. When did we start? Seems like the first video got started about 3 weeks ago. Let's see. Instead of searching through that, we will update like that. All right. That was to be expected. Let's just disable. Yeah, I've been doing this all day with a bit of break. Yeah. Let's see. So whenever let's try. These are not supposed to be run. Let's see if we put a breakpoint here. Does everything run? Yeah. We can actually preload the. Uh, so the preloading itself is not the problem. Is it during the render loop? It might be. Because I changed the code, maybe I need to fix this. Let's see. Let's disable that one. So yeah, here is the crash. So let's see. Our item has the transform index of -1. That is not great. Of course, that doesn't work. So whenever we create our rendering items, we're doing something wrong. And it's during this step. Let's see. Item data, transform index. is -1. But if we look into the game objects, I know why. I forgot to add the part where I actually set the yeah, because we do this manually, we should actually, yeah, this is not great long term, but when we implement a scene slash world container, this will probably be way better. So we assign it to our first transform, then we assign this to the next transform, and the next, and the next, and the next. Maybe we should just do transform index instead, like that. Then we don't do any stupid typos. Yeah, are you doing game development yourself? Let's see. Yeah, it gets set to 0. All right, everything seems to be working then. I think at least, yeah, seems like it. So back to our testing here. Yeah, I think this code is way more robust. I don't know why I got the idea that the components themselves should have the indices. I think this is way better. Then we can release whatever resource and just reuse it. Since we will probably do some memory allocation, which if we reuse resources that are no longer in use, for instance, different components of objects, we will get probably a better memory layout. Yeah, so let's tighten this a bit up. Let's see. All right, we mark it as dirty. We recalculate the particular transform. We can then move this code outside of the actual physics simulation because we are not interested in combining update passes and physics in the same part of the update loop. This just sets the flag for each game object that it's actually dirty because we calculated physics for the particular game object, and it is also related to the actual particles, so therefore only game objects um, where where we have made changes do get passed in. And as I've said, I'd probably prefer to maybe we yeah, I could do another method for that. That would be somewhat more efficient. Anyway, then we want to, before we do our update in the renderer, we would like to uh, iterate over all our game objects and find the dirty ones. Oh, all right then. Are you just interested in programming or something? Oh, you are? Ah, okay. Well, you're probably way more used to someone with far more experience than I. Uh, uh, that's a great place to be. Um, yeah, that's really a great place to be. Um, I mean, programming is a lot of fun. It's like an endless puzzle where where you suddenly realize that the puzzle itself has become incredibly complex. And if you're like me, you end up learning how the actual hardware works. So we iterate over all our objects. We just check if they are dirty. If they are, we compile a list for the renderer. Uh, we only compile a list of pointers. Oh, yeah. Well, then you at least know. Yeah, I felt the same way about C++ when I started. I honestly say at the beginning, I hated it. I loved Java and C Sharp. Uh, and nowadays, I'm more like, well, I do like Java and C Sharp, but I love the control C++ gives you. I think I would like C even more if it's not that verbose. But yeah, the thing about C++ is really uh, getting to know the compiler, what different errors mean, and uh, how all the pointer stuff works. Let's see. Uh, nah. Uh, 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 uh. Let's see. Oh, wait a minute. It's because of the const. Let's see. Whoops. No, we're not supposed to pass it in there. So now we want to compile a list of dirty game objects just by storing their pointer. Um, we can get a reference to the transform itself by asking what transform we're trying to access. Whoops. And store that as a pointer, and then we just create the pointers in place. So the dirty objects gets a pointer, and the dirty transforms gets a transform pointer. and this should compile. Yeah, so now I think we are set up to do some more testing of the render. All right, yeah, of course. It's because we have not updated this, I think. So let's see. At least that's what I think. If we don't do anything here, does it not crash then? It does. So the problem is not that part of the loop. Is it this part of the loop? Or is it the actual creation of the... So yeah, it does spawn the object just fine. Let's see. It spawns the object just fine. So we're iterating over something. Let's see, let's just step into this one. So, does this crash? No. All right, see you later. Have a nice one. Thanks for dropping by. Let's see. So yeah, it's inside that part of the iteration. We have a bug. It's not in the renderer. It's here. So let's just try to step into that. If we ever get to it, maybe the index goes out of bounds way before. Yeah, it does. So it's when we try to access something outside here. Let's just test it out. We should be able to access that. Let's see. Object transform pointer. And let's just store the int particle transform ID index rather. Let's just test that. So we would like to fetch that before we step into the next part of the loop. Yeah, so that is what is not going right. Let's just check the structure. So this particle IDs, the second one has the index of 5. Oh yeah, I'm an idiot. It's fairly obvious that we try to access something that doesn't exist. It's because, or rather, am I a complete idiot? Let's see. Let's just step into it here and check the data again, because so it contains a vector which has 2 points. Or rather, so two vectors with another vector inside. Let's see. Let's just so the particle transform index. Yeah, the way I create this is probably messing with me. So 5, 5. Yeah, I think, yeah, whenever let's see. Yeah, so it has to be 0. Yeah, I think the way this is laid out is not correct. Indices. Let's see. And let's do the same here. Let's store it in the same vector. There we go. That was definitely not correct. All right. There we go. The layout of the vector we created was not correct. Right now nothing happens because perhaps we need to yeah, and it seems to be working. And now they all update. Yeah, great. So now we have dynamic updating of our particles. Whenever a particle is updated, um, um, we could yeah, we could do some checking whether we want to draw these things. Oh yeah, we actually pause the. I think this is supposed to run no matter what. Let's just do a branch here, even though it doesn't matter. Yeah, so now it updates no matter what. Great. I think that is it for this part of the YouTube series. Yeah, we have running physics simulations. I don't think we need this one anymore. Actually, yeah, so we're just gonna do some cleanup. Let's do a headline here in comments. Now, isn't that great? Welcome to all today's followers. There has been a lot of new activity on the channel. Feel free to look up the archive of the videos on YouTube. Yeah, and if you're watching on YouTube in the future, I'm sorry, I kind of do these things simultaneously, which means that I will be interacting with the viewers on Twitch as well. Yeah. If you have any interest in video editing and working without pay, feel free to let me know. Then I certainly would be able to do a lot of material for a total YouTube series where I explain more along the way. The raw footage is definitely providable. Just watch my YouTube video history. Anyway, I think we got the code cleaned up, and now we are able to do some dynamic particle spawning. This allows us to spawn exactly one particle and allocate resources for it. Eventually, we will have to create let's do a deallocate resources slash free resources or rather destroy resources. Part of the application, or rather, maybe a cleanup method. A internal buffer queue for buffer reuse. Yeah. Destroy render items / free resources. Eventually, we would like a more extensive feature in terms of general memory management, but right now it's not needed. Yeah. So I think we would like to do so maybe a particle pipeline to create point-based pipeline, create a shader that does an effect with a point. What's up? Let me just show you what I was talking about. BitConnect. Let's see here. You're in for some crazy ass action. Because I'll be spraying this mofo down. All right, are you looking? Okay, here we go. How do you like it? Lots and lots and lots of bullet spraying. They have no rotation as of yet because they're just placeholders for generic particles. I don't think they're supposed to have a mesh. They're supposed to have some sort of effect instead, but yeah, it still works. They got gravity and collision and everything, so yeah, pretty decent. And we're only running 135 megabytes of memory. This is some lightweight stuff. Anyway. But for you guys following on YouTube, thanks for dropping by. I will be rounding off this episode. As I've mentioned, we will be adding more features to the renderer and create a specific pipeline for the particles. Yeah, so stay tuned. Feel free to comment, like, or subscribe.